guys, welcome for this part. So as we have seen that there are various methods for calculating work, and closely related to work is the energy. Here we will going to introduce that the energy which is related to motion is kinetic energy, and our goal here is to relate work with the kinetic energy, and hence we call it as the work energy theorem. Now let's have a look. Now, as the name suggests, work energy theorem, so therefore let's see that how we can relate work with energy. So in the work energy theorem, we first have to find out the net work done. Net work done means that the work done by all the forces acting on the body. So therefore, instead of writing force in the work done, we'll only write work done net is equals to the net force dot displacement. So for this kind of a situation, we will only use one-dimensional motion with force and the displacement. Let's see how. So as we know that the work done by for the general case, let's consider that force is the variable force. So let's consider that work done will be equals to, instead net work done will be equals to force net dx. So what we can write this as integration f net dx, but the net work can also be written as, so therefore as we know that force net can also be written as m mass into acceleration, and we know that acceleration we can write it as dv by dt, or else we can write it as dv by dx into dx by dt, and this dx by dt can be written as v, that is the speed or the velocity. If we'll consider dx to be the displacement, then this will be the velocity. So therefore this v, so this will comes out to be v dv by dx. So this is what this is written. A is written as v dv by dx. So therefore ma can be written as mv dv by dx. So hence we can write this as f net dx is equals to mv dv upon integration. So therefore to find out the total work done, we have to integrate. So therefore this will comes out to be work done net is equals to mv dv. Since the integration is now with respect to v, so therefore we have to take the limits that what is the final speed and what will be the what is the initial and what will be the final. So therefore this will comes out to be, the result is work done net is equals to half mvf square minus v initial square. That means what we can write it as work done net is equals to change in kinetic energy. This is the conclusion of the work energy theorem. Now thus, so what is the conclusion? Thus a change in an object's kinetic energy is equals to work done, net work done on the object, and this is called the work energy theorem. Now if we say that this is the equation number 1, now with this equation, so as we have done that what is the nature of the work done, so we can say that work done or the net work done can be positive, or let's say greater than 0, it can be less than 0, or it will be equal to 0. So therefore if for the first case, if work done net is greater than 0, that means positive. So what we can write that it's equal to change in kinetic energy. So what we can write for this case, final speed will be more than the initial speed. That means body is doing some work, or force is doing some work to accelerate or in the direction of motion. So therefore the final speed will comes out to be more than the initial speed. Now what about the second case when it will be negative? Negative means that means less than 0. So what exactly we are going to get? V initial will comes out to be greater than V final. That means body is doing or the force is doing work against the motion. So this is what we're going to get V initial. That means V initial will comes out to be lesser than V final. And for the 0, what we'll get that V initial will be equals to V final. Now let's take it out the examples. Now as example 1 is that we have the force of 3 I cap plus minus 1.5 J cap Newton. So let's write it as, this is the force given to us as this 3 I cap minus 1.5 J cap, this much Newtons. Acts on a body of mass 5 kgs. So mass is given to us as 5 kgs. Now body is at a position of this. That means what we can write this as x initial. Initial position is this 2 I cap minus 3 j cap meters. Is traveling at a speed of 4 meter per second. That means V initial we can write it as 4 meter per second. The force act on the body until it is at the position this. That means what we can write, this x final will be equals to I cap plus 5 j cap meters. So assuming no other force does work on the body, the final speed of the body. So therefore, as we have done in the work energy theorem, that means work net is equals to change in kinetic energy. That means, or else we can write it as 1 by 2 m V final square minus V initial square. And we have to find out the work done net. So now work done net. Now let's find it out. What is a work done net? Work done net is equals to, since force, this force which is given to us is a constant force, so therefore what we can write it as force dot S, where S vector is xf minus xi. That means the net displacement. So what we will going to get this as, we will going to get this as minus I cap plus 8 j cap, this much meter. Now this will be the final displacement. So therefore what we can write this as, so work done net will comes out to be force, that is 3 I cap minus 1.5 j cap dot minus I cap plus 8 j cap. Now after taking dot product, what we are going to get, minus 3 minus 12. So this is what we will going to get, and this will comes out to be minus 15 joules. Okay, so this much amount of work done we got, that is the minus 15 joules. So now let's check it out that V initial, now let's substitute the value of V initial over here. What we will going to get, we are going to get this as minus 15 is equals to 1 by 2 m V final square minus V initial, which is given to us as 4 meter per second. Now let's substitute the value. What we will going to get, V final square will comes out to be minus 15 into 2 divided by 5 plus VI square. Okay, so minus 15, this will be minus 6 plus 4 square, and this will comes out to be 10. So V final square is equals to 10, implies V final is equals to under root 10 meter per second. Now as we can see that work done came out, now from this example we can see that work done was less than 0. So therefore what we can say, that initial speed of the body was 4 meter per second and the final came out to be 10 meter per second. So what we can say, that the final velocity is less than actually it's less than the initial. So as we have done it in the theoretical part, that if work done will be negative, so final will be lesser than the initial. Now let's check it out the another example. Another example says a 60-gram tennis ball, mass of the tennis ball is given to as 60 grams, or else it is 0.06 kgs, is thrown vertically up at a height up at 24 meter per second. That means u is given to us, or vi, initial speed is given to us as 24 meter per second. Now rises to a maximum height is given to us as 26 meters. Now what was the work done by the resistive force? Since we have, so we can apply the formula, same formula, that work done net is equals to change in kinetic energy. Now if we'll talk about only about the change in kinetic energy, after reaching to highest point, its final velocity will be, final speed will be 0. So what we can write this as, this will comes out to be minus half v final minus v initial square, or this will comes out to be 1 by 2 m 0 minus 24 square. So what we will going to get? We will going to get this as m by 2, instead with the minus sign, 24 square. Okay, now let's find it out what we will going to get work net. If body will going to, if we will going to throw a body in vertically upward direction, two forces which will going to add, that means obviously that gravity force will be there. So since gravity force will be there, and they have given that drag force will be there, that they are talking about the that means a resistive force, that means resistive force will be there. So their net force will include work done by the gravity plus work done by the resistive force, and this is what we have to find, that resistive force. Now as we know that the work done by the gravity will be equals to minus mgh. Why it will be minus mgh? Because as it will go to a height h, and when we'll throw it in the upward direction, so displacement will be in the vertically upward, and mg will going to act in the vertically downward direction. Like displacement will be in this direction vertically upward, and mg will going to act in the downward direction. So cos 180, so this will going to say that work done net for the gravity work done will be minus mgh, plus the resistive work we have to, this is what we have to find it out. So what we will going to get, so after substituting this value here, we will going to get work done gravity plus work done resistive, and this is minus mgh plus work done resistive is equals to minus m by 2 24 square. So this will comes out to be work done by the resistive force is equals to mgh minus half m 24 square. Since m is given to us as 0.06 into 10, we are taking g as 10 meter per second square, and h as 26 meter, this is given to us, and this will be minus m by 2 0.06 24 square. So this will comes out to be 15.6 minus 17.28. So this will comes out to be 1.68 joule with a minus sign. So as we can see that the resistive force will comes out to be minus 1.68. That means it is showing that it will be in the, or it will be opposing the motion. So guys, in this part we have studied that the net work done is equals to change in kinetic energy, and we have seen examples based on this theorem, and moreover this topic is very important for exam point of view. Now the next topic will categorize the forces, and now for that next part, stay tuned with us.